remaining part. So I already started with this part 9.3, but I'm not sure like how. So once again we'll start from the beginning. 9.3 is purely depending on properties only. If you are clear with the properties, you can solve everything. If you remember, there we discussed with few properties, like the first one, angle subtended at the center is twice the angle at other part of the circle. Angle subtended at the center is twice the angle subtended at other part of the circle. That was the first property which I used. Then the next one, the second property was, if we draw a chord taking diameter as a center, if we take diameter as a chord, then angle of semicircle will be the longest angle. So here angle of semicircle is always 90. That was the second property. And the third property was for a cyclic quadrilateral, always the angles, opposite angles will be supplementary. So those are the few properties which you can recall back to get clear with the explanation. Those properties only I'm going to use today. So here I'm going to start out with the circle topic here. So here in the circle, so what we started with this chapter, if you recall back, I explained you about few concepts of the circle. So let me get started with the things. So if you remember, we discussed with few properties, like angle at the center is twice the angle at other part of the circle. If you recall back, angle at the center is twice the angle at other part of the circle. Then the next one, so let's start out with this. So the first property which I used is angle at the center is twice the angle at other part of the circle. If we consider a circle, angle at the center is twice the angle at other part of the circle. If this angle is 60, this will be 30. So this we call angle at center is twice the angle at other part of circle. So first question is based on this property. You can see here in first question, 9.3 first question, it is given angle made at the center, and then we need to find out angle at the other part of the circle. So here angle at the center, diagram is in this way, you can come across with that. So here in figure it is given angle at the other part we need to find out. We need to find this angle. So here dotted lines are there. One of the angle is given 60 and other angle is given 30. So here two angles are given, 60 and 30. We need to find out this angle. So this is question mark. So first you need to read the question clearly. Here it is given A, B, C are 3 points on the circle. So here it is A, B and C. There are 3 points on the circle. Okay, here it is given B and O is the center of the circle. So this is center of the circle. Angle BOC is 30. So this BOC is given 30 and angle AOB is given 60. AOB is given 60. Two angles are given. One is 30 and one is 60. So what is given part here that we need to fill out first? Here it is given angle AOB 60, angle BOC 30. Now we need to find out if D is a point on the circle on the other than ABC. So ABC is one of the arc and the other one is major arc. So D is the point on the major arc. We need to find angle ADC. This angle we need to find. So let's find how. So this already I told that property. Angle at the center is twice the angle at other part of the circle. So in proof section, first we are going to calculate what is angle AOC. AOC is complete angle. So AOC is 60 plus 30, it's 90. Now angle ADC is half of angle AOC, that is half of 90. So they'll get cancelled. So it's 45. Now what we can conclude here? Here finally that statement we need to write, angle at the center is twice the angle at other part of the circle. So this we need to prove. So this property we used. So here we started with first center angle, then angle at the other part of the circle will be half of that. So final answer is 45. So this is our final answer. The first question is completed. Let's start out with the second question. Second question, here it is given. In second question it is given a chord of the circle is equal to its radius. So here first let's draw the figure. Here it is given chord of the circle is equal to its radius. So figure is given in this way where chord is given equal to its radius. So let this be a chord and these two are radii of the circle. For this question, figure is not given that we need to draw. So these three lines are equal. If O is the center of the circle, AB is the chord. So here it is given AB is equal to OA is equal to OB and all together they are equal to radius. So therefore, triangle AOB, it's an equilateral triangle. So it's an equilateral triangle. So it is an equilateral triangle where all the three sides are equal. In equilateral triangle, we have all angles equal. So we'll make angle A equal to angle B equal to angle O, which is equal to 60. As three sides are equal, so angles will be equal. Now they're asking what is the find the angle subtended by the chord at the point on the minor arc and also on the major arc. So this is called minor arc and this complete one is called major. Major means the bigger arc, minor is the smaller arc. We need to find angle on the minor arc. So here draw an angle on the minor arc, even an angle on the major arc. Now label it, let this be D and this be C. So here we need to find angle ACB, which is angle of major arc. and angle ADB. This is angle of minor arc. We need to find out two angles. What is the angle at major arc and what is the angle at minor arc? So let's start out with that. Now I'm going to use the second property which I told you, like cyclic quadrilateral, opposite angles are supplementary. Here you can see a quadrilateral is there. What is a quadrilateral? It is a closed figure with four sides. So here four-sided figure is there. Now here angle O and angle C. This is angle at the center and this angle at the other part of the circle. So angle C will be half of angle O. Already we got angle O as 60. So in proof part, angle C is equal to half of angle O. That is half of O is 60. So this will be 30. We got the value of angle C as 30. Angle C is nothing but it's the major arc angle. That is angle ACB. Now as I told, there is a relation between angle C and D. So here we can write angle C plus angle D is equal to 180. This we call opposite angles of cyclic. You can use the symbol. Opposite angles of cyclic quadrilateral are supplementary. That their sum is 180. Out of which we got the value of C as 30. We can find what is D. So C is 30 plus angle D we need to calculate is 180. So angle D will be 180 minus 30, 150. So this is the second part of the answer. That is angle ADB is 150. Therefore angle ADB is 150. So this we got two sums completed here. Now let's start out with the third question. So in the third question, it is given like figure is already given. In that question also we are going to use the property of opposite angles are supplementary. The same property we are going to use here. In this figure is somewhat in this way, where O is the center. So upper half there is an angle which is PQR. So here PQR is the upper half angle. We need to find these two angles. So this angle we need to calculate. So how we are going to find out? In this we need to have a construction. So here extend these two lines and join it. Let this be S. So let's go through with the given part. Here it is given PQR is 100. PQR it's given 100. Angle PQR it's 100. Where PQR are the points on the circle with center O, find OPR. We need to find OPR. This angle we need to find. To find angle OPR. Now let's start out with construction part. Here in construction what we are doing? Take a point S on major arc and join PS and SR. So take a point S on major arc and join PS and SR. So this we did construction. Now our proof part will start. So here after joining this complete part will become a cyclic quadrilateral. In proof, PQRS is a cyclic quadrilateral. Therefore, angle Q plus angle S is 180. Same property I am not writing again and again. You have to use that property that opposite angles are supplementary. So here Angle Q is given 100. To find S, subtract 100. So angle S is 180 minus 100. We got this to be 80. Now you can see here, this angle we got as 80. This angle we got as 80. So here the center angle will be double of that. In the previous first question, I explained like angle at the center is twice the angle at other part of the circle. So that property again we are going to use after completion of this. Angle O is equal to 2 times of angle PSR. That is 2 times of 80. So it's 160. Here the statement will come, angle at the center is twice the angle at other part of the circle. Now in this triangle, we are going to use the angle sum property. So the final conclusion part here. Now in triangle POR, angle P plus angle O plus angle R is 180, out of which P and R will consider X. They are equal angle because these two are radii. So opposite angles will be equal. Here angle P and angle R is X. Angle O we got 160. So you need to write reason. OP is equal to OR. Therefore, angle P will be equal to angle R. Let they be equal to X. And you can write the statement also. Angle opposite to equal sides are equal. So here twice of X is 180 minus 160, which is 20. So X is 20 upon 2. So it is 10. We got the value of X. So final answer OPR is 10. Therefore, angle OPR is 10. So this we got completed with the third question. Now fourth and fifth question, they are very easy. So out of this exercise, only two questions are little different. Otherwise, all are based on property only. So this we completed with the third question. Let's move to the fourth question, which is based on the another property. That is, angle of the same segment are equal. So what do we mean by that property? Let's explain me. So here, angle of the same segment. In a circle, if two angles are being started, that is their initial and final position is same. If suppose they are starting from the same point and getting ended at the same point, we call them angle of same segment. And angle of same segment are always equal. So these angles will be always equal. So our next question is based on this property. This we call angle of same segment. So here a chord is there, which is BC, and 2 points A and D on the major arc. Here angle is given 60 and 30, 69 and 31. This angle is given 69 and this angle is given 31. We need to find this angle. So this is the ultimate question. First we'll be finding this basing on the triangle sum property. So here angle sum property of the triangle. So here given angle ABC 69, angle ACB 31. We need to find angle BDC. So this BDC we need to find out. BDC. So first we'll start out from this triangle in our proof part. So here in triangle ABC, angle A plus angle B plus angle C is 180. This is angle sum property. Here A is not given, which we are calculating. B is 69, C is 31, so it's 180. Angle A is 180 minus, add out them and shift there. So it's total 100. Thus angle A is 80. Now you can see that both the angles are being started and ended at the same point. if on the same chord angles are being started and ended, we call them angle of the same segment. They are on the same segment. This is segment. On the same segment, these two angles are there. So they will be equal. Therefore, angle BAC will be equal to angle BDC. Here you need to memorize properties. So chapter is based on properties only. BDC, AT. Here the reason is angle of same segment. So this is what we completed with fourth question. So here 4 questions are completed. Now for fifth question, I want to explain you it orally. So once you try to solve it, here angle E is given. If you have textbook, go through with that. Angle E is given 130. By linear pair, we can find the second half. And then this is also the same sum, like based on the angle of the same segment. Same property we are going to use in the fifth question also. In fifth question, here BC is there. This is E, and this angle is given 130. We can find this angle by linear pair property. We can see here a linear pair is being found. What is linear pair? If angles are on the same line, we call it as linear pair. Now if I'll consider this angle to be 1 and this angle to be 2, so I'm starting out with direct proof. In final question, we need to find out here what is the value of BAC. So this angle you need to find. This is given 20. So to find this, if you calculate what is D, easily you can find A. If we'll be knowing what is the value of D, A will be same as their angle of same segment, forming on the same segment. Here same chord is there, on that they are being formed. So in the proof section, angle 1 plus angle 2 is 180, that is by linear pair. So 1 and 2 is there. This is 130. We can find the value of angle 2. Angle 2 is 180 minus 130. So it's 50. We got this to be 50. Here there is a formation of triangle. Again we can find all the 3 angles of the triangle. In triangle EDC, E plus D plus C. So here when we add all the 3 angles, E plus D plus C is 180, out of which E we calculated 50, D we need to find, C is given 20. So value of D will be 180 minus 70. So it's 110. We got the value of D as 110. Now both are of angle of the same segment. Therefore, we can conclude BAC is equal to angle BDC 110. And statement you need to write angle of same segment. So this is what we completed with 5 questions of this exercise. In my next session, I'll come with the rest of the questions here. Total 7 more questions are, total 12 questions are there. So 7 more questions are remaining. So that will complete in the second half. So in tomorrow's session, if you liked my way of teaching or the explanation, for more such videos, please like and subscribe my channel. So your support is needed for further much more explanation. Thank you for watching. So now I am winding up my class.